Source control is great. Unless you still do this kind of stuff, you're probably using something like Git and GitHub Desktop to save your latest changes. And that's awesome until the app crashes or you messed up your last commit and aren't sure how to fix it. Of course, there's a way to correct this, but knowing the underlying Git commands and how they work will definitely help you manage these situations better. Let's start with the basics. First, we'll create an empty directory in your favorite folder and navigate to it using the command line. Then comes the first Git command, git init. This will create a new repository in the current directory. Now we can check the repo's current changes. Let's try git status. Of course, there's nothing there. Let's add some changes. I've added some files and we can now see them in the command line. Right now they're untracked, which means Git does not know about them. We can add one with git add. Now it shows up in our staged changes. We can also add folders or the entire repo. There may be some files or folder that we don't want to keep track of. For instance, this code editor config folder. We can fix this with a git ignore file. Great! Now all our changes are ready to be committed. To commit, we'll use git commit. But don't press enter too fast or else you'll end up in a Vim window. This window lets us type a message for this commit, but in order to use it, we have to learn Vim. This subject will be for another video. If you did press enter and are stuck in Vim, don't panic. Just type :Q and press enter. Now in order to commit without going through this, we need to pass the M option like so. And that's it. You successfully committed code. You can see your commit with git log. To exit the log view, press Q. Now if I introduce more changes, notice that the file I modified is not shown in untracked files, but in changes not staged for commit. That's because I changed the file that Git was already keeping track of. If I want to commit these changes, I can either add the file with git add and commit it with git commit, or I can do both in a single command by passing the A option to git commit like this. Perfect! My changes have been committed. The next step is to create branches. For this, we'll use git branch. Running this command creates the branch, but it doesn't switch to it. Running the same command without the branch name will show a list of all your local branches. Just like git log, press Q to leave the branch list. To actually switch to the new branch, we'll use git checkout. Now when we check the status, we can see we're on the new branch. We can also see the active branch in git branch has changed. Let's go back to the master branch and create a new branch again. Only this time, we'll create a new branch and switch to it only in one command. If the B option is used with git checkout, Git will create the branch before switching to it. Obviously, branches are not of much use if there's nothing in them. Let's add some changes to our first branch. I've made some changes to the project, so I'll commit them. If we consult the git log, we can see that our latest commit was done on a different branch. Now let's bring those changes to master. As you can see, the changes I made in my branch are now present. We can add them using the git merge command. In this case, the merge was simply a fast-forward merge, meaning Git moved the master branch's head one commit forward. We'll handle more complex merge scenarios in a future tutorial. Once a branch is merged to your repo's main branch, it's common practice to delete it. For this, we'll use the git branch command with the D option. My branch is now gone. Creating commits and branches locally is fine, but typically you'll want to save your changes in a remote location. Who knows what might happen to your laptop? Let's set up a GitHub repository so we can push our local repo to the cloud. From here, we'll connect our local repo to this remote. We'll either need the HTTPS or SSH link. I personally prefer dealing with SSH, and if you've never set up an SSH key before, make sure to follow GitHub's instruction that I'll have linked in the description. So copy your chosen link and back to the terminal, we'll type git remote add origin and paste the link. The local repo is now linked to the remote one on GitHub. However, nothing has happened yet. We'll need to push our branch. Git push is the command we'll use. Notice that sometimes Git will return errors, and if you don't pay attention, you may not realize that your work was never pushed. Here the problem is that Git does not know what to push to GitHub. You're currently on master, but your remote repository has no branches. Think of it as a new repo, and you need to let it know what branch you want your local repo to push to. Let's keep it simple and set up a branch with the same name. We'll add to the git push command the --set upstream option, or -u for short, and we'll specify the remote name and remote branch name. Hooray! We successfully pushed code to GitHub. If we refresh our browser, we'll see that our remote has the same code as our local repo. Another thing that changed is when we check our repo's status, we see on the second line the message, "Your branch is up to date with Origin Master." This confirms that we successfully set our master branch to track our remote's master branch. Now let's say someone else clones the repo and pushes changes. We'll need to keep our local repo up to date with the remote. To simulate this, I will add a README through GitHub. Now that I added some changes with GitHub, I'll update locally with git fetch. This updates my local repository's reference to the remote. Notice that when we check the repo status, we can now see we're behind the remote by one commit. We'll run git merge to update our local branch. Knowing about git fetch and git merge is important to understand the difference between updating our local reference of the remote and actually updating our local branch. That said, you'll want to use git pull most of the time since it does both commands in a single call. We now see the README file that we added on GitHub, but there's a typo. Let's fix it. Now we can commit our fix and push it to the remote. The fix is now online. Now that we have a functional remote, let's go back to an earlier command. If we run git branch now, we'll see our local branches but none of the remote ones. To see the remote branches, we pass the --all option, or -a for short. We can now see our remote branches as well as our locals. As you can see, our remote has master, but not our second branch. That's because we need to push branches individually to the remote. Let's simulate a typical feature implementation workflow. We'll switch to a new branch, implement a feature, push it to GitHub, and open a pull request to merge the code. Hey, someone just submitted a pull request to our repo. Let's check it out. I see. A very important feature. Personally, I don't like Skittles, but you shouldn't let personal preference interfere with a code review. Normally I'd approve it, but since I created it, I can't click on approve, so I'll just merge it. And just like before, a merged branch has no purpose, so let's delete it. If I were to ask you at this point, what branches are on my local repo, what would you say? Is feature important still there? Let's find out. Now, of course, since we didn't pull, there's no reason for the repo to be up to date. You might notice a message in git's output of the pull command telling you no ref was fetched for feature important. We'll get back to that later. First, let's see if our branches were updated. The remote branch is still here. That's because git will not clean deleted remote branches by default. In order to clean up deleted branches on the remote, we need to prune it. The command is git remote prune origin. There we go, no more dead branches. Of course, you'll have to take care of your local branch by yourself. If you forget to pull master before deleting the branch, Git will let you know that you're trying to delete a branch that was not merged to its base. It's pretty handy to prevent accidentally deleting unmerged work. In our case, we merged in GitHub, so we'll just pull. There, our repo is clean. Now that you know the commands to set up a local repo, commit changes, create branches, merge them, and do all of this with a remote repository, you no longer need an extra tool to benefit from Git. Hopefully this guide has given you a greater understanding of how Git works and will allow you to manage your code more confidently. If you found this video useful, don't forget to like and leave a comment below. Thank you for watching.